as that. That's the body of the loop, just like the body of the while loop. So first time I will be 0, and 0 is smaller than 10. Okay, you print I plus 1 and append the square of that in a list. Then next time this range will automatically return the next number into I. Now next time I will contain a 1. Next time I will contain 2. Next time I will contain 3, 4, 5, 6, 7, 8, and 9. Once the value of I becomes 9, that's the last iteration of this body of the loop, and after that the loop finishes. So let's just try run this. Very first time I will be 0. When the loop enters its body very first time, I will be 0 and 1 will be printed because we are printing I plus 1. At that time the list and the empty list will be having one number, which is 0 square. So list will be having just one number, 0, because 0 square is 0. Next time I will be 1 and we will print 2, and the list will contain 1 square, which is 1. Next time I will be 3, I will be 2, we will print 3, and we will be having a square of 2, which is 4, and so on till 10 here. When the I will be 9, we will print 10, and in this list we will be having 9 square, which is 81, I guess. And after that the loop finishes and we will be out of this loop. Okay, let's see this. Let's see example of this in Jupyter, just to get more comfortable with the list as well as the for loop. So let's see. Let's say we have an empty list. Let's say an empty list. Just consider a list like this. L is just a variable. You can write another variable name. That's a variable name L. Okay, so for I in range, in is a keyword, range is a function, in is a keyword. I in range, for example, let's say 10. What you do is you print I plus 1 or whatever you want to do. That's the body of the loop. And L dot append, that's a function of the lists. We will see that in detail in the data structure sessions. Okay, and that's it. The loop finishes. When you finish the loop, just print the whole list. So let's say print the list, and you can see the result 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's these are the values in the list as I mentioned earlier. All these are the values. By the way, this range function actually, what if we want I to jump more than just 1? For example, we want I to start from 0, it reaches 10, and let's say we want the jumps to be taken as 2 rather than 1 and 1. So the very first time, so that's the start location, that's the end location, which is not included. Start location is included, end location is not included, and that's the step size. So very first time I will be 1, you move inside, then a jump of 2 will be taken. The next time I will be, so very first time the I will be 0, then you move inside, then the jump of 2, then you move inside, then a jump of 2, then you move inside. As long as you stay smaller than 10, you will move inside the loop, body of the loop. So let's see what now printed. Let's print just I rather than I plus 1. Oh, there's an error. What's the error? 0. Oh, the range function does not have colons. It has actually commas. Sorry, my mistake. I was just a Matlab user once, so Matlab actually has these colon things. So I was just confusing Matlab notation with this. Okay, great. So so first time I was 0. Next time a jump of 2, I becomes 2. Next time a jump of 2, I becomes 4. Then I becomes 6. Then I becomes 8. And next time I becomes 10, but 10 is not included, so you're out of the loop. And that's the squares that you got. It is not necessary that you always start from 0. You can start from 1, and you can take a jump, for example, a jump of 3, and it's not necessary that you just reach 10. You can reach, for example, 20. It's up to you. It's completely your choice. And in that case, you have this kind of iterations. So this range function really is helpful for iterating over over a loop body or a structure. Okay, great. So that was introduction of for loop, and we have iterated here on a list. We just have actually populated a list using for loop. Okay, in the next video we will see more details of this for loop and more fun stuff. Okay, hope to see you in the next video. Last time we saw a for loop in the last video, and magically this else has something to do with for loop in Python. Well, this else clause makes sense for if, but in for loop it hardly makes sense. But let me try to make sense of else clause for loop. There is an else part of for loop as well in Python, not in other languages. I don't know any other language that has this else part. Maybe there is some, but I don't know. So this else part in Python, particularly in for loop, this else part or else block will only execute if for completes its iterations. For example, this is a set. A set like a list is a collection. List is defined by square brackets. Set is defined by curly brackets. The set is just similar like the set in mathematics. We will see the set, lists, tuples, dictionaries, and many of these data structures in detail in data structures portion, but just I have introduced this. Just consider this set has 3 elements: apple, 4.9, and cherry. Apple is one object or one data. 4.9 is one data, which is a floating point data, and cherry is one data, which is a string data. Okay, so this S has 3 elements, 3 different elements. So now for X in this set, as long as X is in the set, the very first time the X will be apple, so it will print apple. Next time X will contain a 4.9 as long as, so iterate over this set. As long as X is inside the set, pick elements one by one and just print them all. Okay, we expect that when X is apple, when the very first time X will be apple, it will print apple. Next time X will be 4.9, it will print 4.9. Next time X will be cherry, it will print cherry, and the loop ends because there is no item in set to iterate over. Because the loop finishes its complete iteration, there are expected 3 iterations and the loop finishes those. Now the else part will execute and you will say, okay, loop completes its iterations. Well, you will be wondering in what case the else will not execute. If you apply any break statement inside the loop body, which means you forcefully remove some of the iterations that were going to be executed, but the loop did not complete its iterations, then the else part will not run. So let's see an example in Jupyter to get a good grip on this else. Okay, let's define a set. S. S is a variable name. You can have any variable name. Let's say apple, or let's say 4.9, I guess. And then we was having, let's say cherry, if these spellings are correct, I guess, cherry. Okay, then for X in S, as long as X is in S, print X, fine, else, print when you finish the loop terminates with success, or all iterations, it completed all its iterations. And this is a statement that is completely outside the loop. Outside the loop. So let's run this. So you can see apple, 4.9, cherry, loop terminates with success, outside the loop. Okay, now you might be thinking in what case this else will not execute. Okay, if for example as long as X is in N, if I say, okay, let's say I take a counter here, I equals 1, that's a counter, let's say, and every time I just increment I plus equals 1, and then I check if I is equal to 3. If I is equal to 3, then just break, let's say. Else, just for readability, else pass. Now this else is else of this for, and this else is else of this if, and this pass statement is just a statement for doing nothing. Now what you do when I is equal to 1, you print this, I plus equals, I becomes 2, 2 is equal to 3, false, so you pass, you move on. Next time x will print 4.9, I will become 3, and 3 is equal to 3, that's correct. The break will execute, which means the loop should have one more iteration, but the break just disrupt that one more iteration that should be there. Because the loop could not complete its iteration due to this certain condition, this else part of the loop will not execute, and you will go directly outside this loop. So let's run this code and see the result. So you can see this, Apple 4.9 outside the loop. I would recommend also this else is there for loop, but I would recommend to avoid using else in the beginning. I mean, you may be confusing this else. By the way, there is a mistake here. This else should be ended with a colon here. Okay, so I would recommend to not use else clause for a for loop in the beginning until you really need it, because you may confuse this else with the else of if condition, and you may think something else and the program behave in a different way. So either way, if you want to use else for a for loop is there in Python. Okay, just one more example of for loop, and here we use dictionary. I'm introducing some data structures here just for fun. We will see these data structures in detail later on. So dictionary, that's a key value pair. It is like a set, but one item consists of two numbers. That's called a key, and that is called a value. That's a key and that's a value. Like a dictionary, we have key and values. So now as long as x is in x, x represents to key, and d is our dictionary, and d of x represents to whatever value that x points to. For example, apple is a key that points to 44. Cherry is a key that points to game. For example, if I write d apples, apple, the result will be 44. Similarly, d of cherry, the result will be game. Okay, so let's iterate over this dictionary using this for loop. All am I showing you that this for loop is very, very handy of iterating over different data structures and a lot of data and stuff. Whereas while loop is more handy in checking the conditions and stuff. Although you can do all the stuff using while loop, you can all the stuff using for loop, but one is better over the other in certain situations. So let's just run this for a dictionary. Let's say I have a dictionary D. It's defined like a set. Let's say my key is A and my value is 10. Let's say my key is B and value is minus 19. And let's say my key is C and my value is, let's say, ABC. Let's say that's my dictionary. So for x in D, print the key as well as the value of that key. So now you can see the key is A, the value is 10, the key is B, the value is minus 19, the key is C, the value is ABC. So this for loop is really, really handy in iterating over a lot of data structures and stuff, although it has other applications as well, but this is handy. Okay, great. So that's about loops. For loops and while loops. These are two kinds of loops in important loop. These are two important kind of loops in there in Python. In the next video, I will directly go to Jupyter Notebook, and we will be practicing for this for loops or while loops. We will be practicing the loops. We will be doing actually examples of nested loops. We will be actually solving a problem like we did in the if conditions. We solved a problem previously. We wrote a code for it. Here we will also write a code, and we will get a good grip on the loops. So hope to see you in the next video. We will solve a problem in Jupyter Notebook directly. Okay, hope to see you in the next video. Okay, welcome back. In this particular video, we are going to practice for loops, or basically loops. So let's have a problem statement first. What problem we are going to solve? Let's have comments. And the problem we are going to solve is, let's define given a list of numbers, for example, i.e., let's say 1, 2, 4, -5, 8, 7, 9, 3, 2, like this. Make another list. Make another list that contains all the items in sorted order from minimum to maximum, i.e., your result will be another list like, in this particular case, we will be having -5, which is smallest, then we will be having 1, then we'll be having 2, then we'll be having 2, then we'll be having 2, then we'll be having 3. So all the items, but in minimum to maximum sorted order. Then we'll be having, I guess, 4, then we'll be having 7, and then we'll be having 9. So that should be your output in another list. So assume this list is available to you, or any list is available to you. Assume this list is available to you. So how to solve that problem? Let's start. Okay, let's assume that the list is available. Let's say this is the list we are going to sort. Let's say this is available. Okay. Okay. So what should be the logic? What should be the logic? How can we solve that problem? This is an easy looking problem, but it is not so easy. Let us first write let us just simplify this problem to just finding out a minimum from the list. Let's say we are given a list and we just want to find out minimum number, one minimum from the list. So how can we move that? So let's say m is some number. So m is the very first value of the list. M is our variable, let's say. That's the first value. And what we do is for i in L, as long as I is in L, if I is smaller than m, then if I is smaller than m, then m should contain I, otherwise do nothing. That's it. So at the end, print this m. Print this m at the end. So print the minimum number. That's m. Great. So so that's the basically so yeah, that's the that's how we will find out just the minimum value. So let's run this code, and the minimum is -5 available to us. What if we want to store the minimum value as well as the position of that value? For example, we not only want to just find out what is the minimum number, we also want to find out at what index. For example, here 0, 1, 2, and 3. At the third index, we found the minimum. What if we are interested in the index as well? So let's say for the very beginning, the index is 0. And then what we do is we moved on, and we say, okay, we maintain a counter. Let's say a counter is c equals 0, for example, right now, and c just plus equals to 1. That's a counter. And then this idx is just that c, whatever that c is. So whatever that index is, when we find this c, that index is also there. So let's print the index as well as the minimum value. So okay, so at the position 3, at the index 3, we found the minimum value. Okay, now we have written kind of a code block that helps us finding out the minimum value. How can we actually so the basic logic is you find the minimum value and swap that value with the very first value. Okay, great. And then move the loop. Next time find out the minimum value from the remaining list and swap that minimum value with the second value. Next time you find the minimum value as long as the position and swap that with the third value, and so on. So do that stuff and just rearrange the same list using this. But how can, so that's the logic. Find out the minimum value, swap it with the first value, and then start from 2 till end. Start from the remaining values, find the minimum, swap it with the first value of the remaining list. Then reduce the list step by step, and you will be having a sorted order. But how to start with? How to find out like this? How to do that? So any idea? I mean, we are going to, so for example, in this particular case, if I want to swap the list, what I will do is I will say, okay, swap with 0 at the 0. So I will contain a temporary variable. Temporary variable will contain the value of 0, list 0. So what I will do is at list 0 write the minimum value, and the minimum value, so at 0 you write the minimum value, but at this particular index from where we found the minimum value, just place the value at the very beginning. So after that operation, the minimum will be at the first position or the 0th index, and that value will be, so minimum value will be swapped with the very first value. So let's run this code and see what a list looks like after that code. So you see, for example, the minimum value is swapped by the first value, whatever the first value was. But we want to do that progressively for the rest of the list. We want to find out the minimum and swap with the first one for the rest of the list and keep on moving. How can we do that? So yeah, so let me define for, so let me first indent that a bit. Let's say control right braces, that will indent all my code. So for j in range length of the list, whatever the length of the list, let's say for j is that. So what I do is m is the jth value, the index right now is j, and the c is also the counter c is also starts from j. Okay, great. Now we want I to start with now we want this I to start from j and move onwards. Yeah, so let's say I in range, start from j and go till length of l, one by one, take the step of 1. Okay, great. So what next? Now the value will be L of I rather than simply L of I rather than simply I. In that case, you do this. Okay, and the index is just C. Okay, great. Keep on introducing this index again and again. After this loop, what you do is you pick the jth value, you swap the jth value with the minimum, and you do that, and that's it. You keep on moving, and after the outer loop finishes, if you print your list, you will be having the list sorted order. At least we hope so. So maybe there is a bug in the code, maybe there is a problem in the code, but we hope this will work. what we are doing progressively. By the way, this is a nested loop. This is a loop inside the loop, and that's and then we have an if condition inside the nested loop. Loop inside the loop. Great. Let's see how it works. If there is no, oh, there is an error, length of range. Oh, we haven't write a colon there. Don't forget this colon. That's a problem. Oh, we have a sorted order. Oh my God, we have a result with us. You see the applications of this. Oh, 1 3 is missing. Where is 3? We have 2 3s. Oh, the output we have written here is wrong. There's no 2 3s. There's only 1 3. So you have sorted a list. If you remember, we have written a similar kind of code in the problem solving session very earlier, where we solved this problem using selection sort. But there we just wrote a pseudocode, and here we have a code much simpler than actually the Python code. If the problem was just sorting, there are built-in functions to do that, but I'm just telling you how these loops and if conditions and all that stuff can be used to communicate with each other, to match with each other, to actually perform a problem-solving task when given a problem. Although we will see later on in Python, most of the problem-solving tasks, I mean many more of them, there are built-in functions for those, there are available functions for those. You need not to write all that stuff, but to master any programming language, you have to go through these constructs, so that for a new problem or for a very large complicated kind of problem, eventually you may need these kind of structures with you. So mastering these structures is really essential for problem solving and programming in general. So okay, that's about the loops and if conditions and control flow, all of that. In the next video, I will start talking about functions. So you have seen this len, that a function. You have seen this range, that's a function, iterator. Although you have seen a round function, you have seen div mode, you have seen print function. What if we want to write our own function? How can we do that? From the next video, I'm going to show you how can we write our own function. Wow, isn't that great? That's great. So hope to see you in the next video. In this video, I will talk about functions, a very powerful construct in almost every programming language. Python also supports functions. What a function is, let me describe the need of the function by a scenario. Let me give you a scenario. The scenario is, let's say you are writing a very lengthy program. The program requires to print particular messages whenever needed. For example, you need to print this particular message, the task was successful. Let's say you need to print this, and then you have to print moving to the next task, maybe to inform somebody, maybe to inform your client, and then you have to ask, okay, send me the next task because I'm done with the previous task. Let's say you want to print this, or maybe you want to print more or do some more stuff. And let's say you want to do this again and again whenever needed. Somewhere, whenever you complete a particular task or something, you want to print all these messages. And then somewhere else, whenever a particular event occurs, you need to print all these messages again. Now, one way to do that is to write just these print statements whenever needed in the program. One way is, if you want to perform a task and the task has a lot of coding, maybe very small amount of coding, or maybe a very large amount or magnitude of the coding. In this case, we have just 3 statements, but maybe we have a task that we want to perform again and again, and it is really a very lengthy task in terms of the coding. So one way to do that is to just write all the coding in coding somewhere and define a function. And that function means the function contain all the tasks that you need to perform. Whenever you need to perform that particular task, just in your coding, just call this one statement, just this one statement, and the whole task that is written under this, maintaining this as a heading, that will execute automatically. I mean, however, that task that is under this heading may be very lengthy, may be short, may be complicated, may be simple one, or anything. But the need is we want to perform this task whenever we need, and we do not try to code this again and again. We do not want to write the same lines of codes again and again and again and again in our program. Just write this particular lines of code once, define a function just like a task. Whenever you need to perform that task, just call the heading or the name of the function, and the whole task under that function will execute. Functions in almost all programming languages, they do that. Even in mathematics, they do that. In Python, the syntax of defining function is if you want to define a function, you have to first start with DEF, meaning definition or defining. Then you need to write the name of that function. The name of that function, name of function and name of variable has resemblance. I mean, the name of function should be descriptive. It should portray what the function actually is doing. So it is good to write, it is good to suggest the names of the functions that are very descriptive to make the code readable and manageable. So here I have written the function name as print success. You can write any name. Then you start parentheses, then you end parentheses, and then you write a colon, like you have written the colon for if conditions or for loops or any other constructs. And then you do indent like the body of the for loop, like the body of the if condition. This is the body of the function. Body of the function is should all be aligned. Then you write all the task, all the coding that you need to be performed whenever this function is invoked or called. This body can contain if conditions, for loops inside. I mean, this can have a whole lot of coding inside it. And whenever you will call this function, whenever you will type this command, wherever in your coding, the whole task under this will be executed automatically again and again whenever you like. So let's take a look of defining our first function in Jupyter Notebook. Let's just, I guess, yes. So yeah, so that's our notebook. We were populating that notebook. So by the way, if you want to know where this notebook is located, if I want to, for example, invoke that notebook again, when you will run your Jupyter Notebook from the Anaconda prompt, you'll be having all the files that you are working on. And one file is, for example, this. You just click on that, and your file, one or more files, whatever you want to open up, that will open up in the Jupyter Notebook. Yes. So it is opening up. It's a lengthy file, so it may take a second. Okay, let me just take a better zoom level just to, okay, so we were working on that notebook. Let's define our first function. Let's say def define. Let's say the function name is print success. That's a syntax. Then you press enter. Print I am done. Then print send me another task, let's say, and that's it. Let's say that's the body of the function. The body of the function here contains only 2 statements. Okay, then you run this command just like shift enter. You run this so that it is reported in the symbol table. There is a symbol table inside the Python is maintaining all the variables, all the function information inside. So once you run this cell, then this print success function will be registered to Python, so that whenever you want to call this function again, it will be available. Now, if you want to perform this task, let's say you want to perform this task whenever you want. So you just call this function. This is called calling of the function, whatever I'm doing now. Print success, and that's it. You press shift enter, and all the statements that are under this will be executed. And you do some other stuff. Let's say 3 plus 8, that is 11. Do some other stuff, and afterwards, if you want to do the same process again, then you call this function again, and all the coding inside the function will be executed. It is very, very handy if a particular task, if you want to perform that task repeatedly, it is good to just write one code for that task in a function and then just invoke function whenever you need. It supplies a lot of managing power, a lot of debugging power. If you have an error, for example, inside the function, you just go to the code, you just go to the code of the function itself and fix the error and come back. You need not to go all over the code. If you have not defined the function and you have called these lines of codes everywhere inside your main code, then it will become very difficult to handle. And function actually provides a lot of simplicity of managing and readability and a modular approach in that sense. So that was our first function. We will be talking about more. We will be talking more about these functions in the next video. So hope to see you in the next video. The function name should be descriptive. That's okay, but it is further important sometimes to have a documentation of the function, sometimes called the doc string. The doc string allows you to write the description of the function, but that description will never be executed. It will be available whenever you need help or you need to know what this function does. Sometimes it happens your function can contain a lot of code. For example, you have a particular function, let's say fun, let's say it contains def fun, and it does a lot of complicated stuff inside, and it is sometimes required to know what this function actually is doing. So this document string is one way of describing what the function is doing. You might be thinking that if you're writing this document string inside where the coding of the function should be written, we should open up the coding file and see what the function is doing, or should we actually open up this function implementation where the function code is written and then we have to read what the function is doing? Actually, Python gives you another power. If you have written the document string inside, that should be a top statement before the first coding statement. Whatever description you want as a document string, it will be available without actually opening up, without actually seeing what inside the function, without actually opening up the file that contains the implementation of this function. Let's see in Jupyter Notebook in more concretely whatever I'm saying right now. So for example, let's define a function def print success 2. Let's say the function name, this function is print success 2. The function name is print success 2, although it's not a very descriptive name, but the spellings are also not correct, but that's fine. Print success 2. Here I just define a document string. The document string may contain maybe just in one line, or it may be a multi-line. It is like a multi-line comment, or maybe a single line comment if you want. But it starts with 3 quotes and ends with 3 quotes. Let's say I write here, this function is doing nothing except printing a message. Let's say full stop. And then I further define, let's say I define more in saying that message is hello, let's say, or any description you want for this function. Now this is a document string and it will be available whenever you need. Now here the coding starts. Let's say you write a coding here and you get hello, let's say, and you run this code. Now let's say we are not seeing this function. We are not available with this function. We are not available with the code of this function, and we want to know what this function actually does. First of all, we can just write, if we write pri and just press tab, the tab will allow us to access all the functions that are available with prefix pri. So let's say we go to print success. Here print success, S should be capital, print success, let's say. So print success 2, let's say. and we write a question mark in front of it, and then just press Shift Enter, it will pull the document string. It will pull the document string, whatever we have written, and we will get to know what actually this is doing. So this document string actually does a lot of job. Further, if we, I mean, this is kind of whenever we need to know what a function is doing, the document string is one way to just go and check what is happening. Right now, this function implementation is in front of us, but in several times the function implementation will not be in front of us. Several times we will be accessing functions that other people have written in their libraries. And we need to know what those functions are doing. So document string is one very, very healthy way of describing our function. And I will recommend to make your habit writing document strings every time you write a function. I was telling you that if you write a double question mark, then it will not only pull the document string for you, it will pull the whole implementation as well. So now if you see, this is the document string and that's the implementation. So whole implementation will be available if you want. And this is true for the functions that are the functions that are third-party functions, or some other person have written that function and so on. For example, you know a function length, we have called that function several times. So let's see. So the document string is return the number of items in a container. That length function is not written by us. Somebody have written that function. That's a built-in function, by the way. And this document string tells us, okay, what this function is doing. We don't have the implementation of that function. Obviously, somebody have written that function. And if we write the double, then we should get an implementation as long as the implementation is not in C++. I haven't told you that a lot of implementation of Python itself has been done in C and some other languages, C mostly. So several built-in functions, because of their speed, they are implemented in C. And if you want to get their implementation, get their code, the code will not be available for most of the functions. So whenever you write a double question mark and the answer is the same as a single question mark, that's an indication that this particular function is not written in plain Python. It is written in some other language and is used in Python. That's another versatility or flexibility of Python. You can engage multiple languages inside. Okay, one more thing. I can write help command, and I can get this print success to the help of print success to by just typing this help command. So this help will tell us, you see, the help is telling us the document string. I mean, this help on this function. And this is the function we have written. This is the function we have written. This function is doing nothing except whatever description we are giving there. If at some time, if we are supplying this function to somebody or making a package of a lot of functions that we are writing, these document strings will help to get to know how to use these functions. By just knowing the function name, this document string actually tells us what the function is doing. Wow, great. Oh, by the way, we haven't called this function yet. We are just playing with the document string. Let's call the function print. Now we know what the function is doing. Let's call this function. And whatever written inside the function will be called. See, this is only called, this is just acting as a comment, and it is basically a comment. Yeah? Okay, great. Stay with us. There is much more about function that we are going to tell you. Hope to see you in the next video. Okay, in the last video we saw document string. You might be thinking, what is power of this function if it is doing some static task? Well, in this video I'm going to tell you that the function the coding or the behavior of the function can be dynamic based on the arguments, based on some properties that you will be defining at the call time. For example, the function has, in almost all programming languages, the most interesting functions are the functions that receives an argument, and an argument is just considered an argument just as a variable, and performs its task according to that argument. just take a simple example. Let's say rather than having a function print success, we have a function print message, and it prints whatever message it receives. And at the call time, for example, we call this function like so print message, and let's say we call this as let's say success. Let's say now success will be printed. Next time we call the function and we give another argument, maybe in a string, let's say 74 errors, let's say, that will be printed, or anything. I mean, anything that you supply will be printed. Wow, isn't that great? I mean, one function, and you might be thinking, the plain print function does that. What's the power of this? Well, I'm just telling you, the function does not only contain one line. I mean, it can be a whole task depending upon this input argument, and the whole task will perform dynamically based on what input argument you are supplying there. You are noticing one thing that I just forgot. What is that thing? I defined this function. I guess everything is fine. I've just missed something. Oh, document string. I should have written document string. Although document string is not essential, if you do not write document string, it's perfectly okay. The function will run, but it's a good practice. It's a good habit to always write a document string. Okay, let's see the power of input arguments by, again, going to our good friend Jupyter Notebook. Okay, so let's see. Let's say we define a function, define print message, let's say, and it receives an argument message. And this argument is just a variable. It's just a variable. And let's say we say, okay, print message. Or further, let's say we say if is instance message string. If this is string, then simply print it. If this is not a string, then just say okay, print your input argument is not a string, and then you say okay, here is what you have supplied, and then you say okay, whatever you have supplied, just see okay message, and that's it. That's a function. We might have written a document string for it. The function prints the message supplied by the user, or prints that message is not in the form of string. Wow. Don't worry, we have to see the strings in detail. We will see this print function in detail as well, because this print has a lot to do with strings. So just for now, I mean, that's our function, print message. Let's say if the message is of string type, this string does not, this should be simply str. This should not be that, is instance take like this. Your input argument is not a string. Here is what you have supplied. Here is what you have. So here we can say here is the type of what you have supplied, and then we can just print the type, type of MSG. So the goal here is to just write a function that prints a message if that message is in plain string form. If it is not a string, then it prints that okay, whatever you have sent is not a string, it is not a proper message in string form. Let's say this print message function receives a string, let's say. That's our logic or something. So let's run this. First of all, let's see what it does. Help print message. So the function prints the message supplied by the user. We can access the same help by question mark if we want. And it gives us the document string. If, however, we want the implementation as well, then we write a double quote and the implementation is also available. Wow, great. Python is really great. Okay, let's call this function. Yeah, let's call this function. Print message and whatever you want to print. Let's say this is the message. This is the message. Let's say you want to print this. And this is the message that's printed. Okay, now let's say you call this function again sometime and you supply 23. And it will say your input argument is not a string. Here is the type of what you have supplied. It's an integer type, right? You can call this function in the following way. Let's say you define a variable y, and the variable y contains hello. Hello there. Let's say that's your, and then you call the, then you call this function on y, and it will print hello there because y is also a string. Great. So that's how you can pass different arguments and instruct the function how should it behave without actually writing the whole logic of the task again and again. You have written all the logic once. Actually, the logic starts from here. That's what the task is to. That's what the task you want to perform, and you need not write this again and again whenever you need this kind of stuff. You just call that function, supply it arguments, and it will behave accordingly you want. Great. So you might be thinking that a function only receives one argument. Maybe we want to supply more than one arguments, maybe 2 arguments, maybe 3, maybe 4, maybe 5, and maybe we want to supply several arguments, and we want to do some task based on the values of those arguments or those variables. So in the next video, I'm going to show you multiple arguments. Okay, hope to see you in the next video. So in the previous video, we saw we can define a function and we can supply input argument to it. And in this video, we are going to see that we can actually send more than one arguments to the function. These arguments are just variables. These are just variables. Whatever value we will supply to these dynamically, because Python is dynamically typed, dynamically their type will be defined. And for example, here we have supplied just 2 variables and we just printed them. But based on supplying more than one input arguments, and based on what logic we are going to perform, we can do anything. We can do anything. Yes, Python allows us to supply multiple input arguments to a function, and we can just perform all the tasks according to whatever logic we are going to do with that. So let's go to our friend Jupyter Notebook and see an example of a function with multiple input arguments. Let's say the function we define a function. Let's say my power. Let's say my power. Let's say you remember there is a POW function in Python. That's a built-in function. I'm going to write my own function. Let's say it contains A and B. Well, document string. This function computes power just like built-in power function. Great. That's the document string. Okay. Now what we want to do is we want to print. Okay, let's create another variable c that is a power b. Okay, then we print this c and we are done. Let's say that's our goal. So we register that function by just calling by just pressing the shift enter in Jupyter Notebook, and now we check what this function does. Well, this function computes power just like built-in power function. Okay, just to remind you again and again the importance of document string, I'm writing this again and again. Let's run this function. My power, let's say 3 raised to the power 4. I want this. So the result is 81. Oh my god. So whenever, by the way, if you don't have POW function with you, although you have, you can create your function, and whenever you want to use, you can use your function. Not a big deal. Yeah. By the way, what if you you can define a function with more than 2 arguments. Define, let's say, display types. Let's say that's your function, display types, and all you know is or check arguments. Let's say check args. Let's say that's your function, and A, B, C, D, let's say E, these are the input arguments. And let's say at some task you want to know whether all the 5 variables that you're working in somewhere, whether all of them are numeric values or not. If they're not numeric values, you're not moving on and you are doing something because you were let's